Okay, our next speaker is Dr. John Percy, Toronto Centre, former editor of the Handbook, editor of the Journal. No? You know, why didn't you take on that job? Past president of the Society, gold medal, Toronto gold medal winner, past honorary president, past president of the AVSO, past editor of the AVSO Journal. He's been involved with the IAU Education Committee.
That's for tomorrow night.
Okay. So anyway, I don't want to tell too much. But anyway, John has been a great supporter of the RASC and education public outreach for many years. Oh, okay. I wasn't going to say that, but but he has a great interest in the heritage of Toronto and its astronomy, and he designed a walk through downtown. Here's John.
Okay, good morning. How many of you are from the GTA? And if you know what that means, you probably are. How many of you are from away? Okay, so this is intended for both groups, and as the title says there, the sub-theme of this talk is how astronomy is developed in Toronto along with the development of the city and the country. Now, anybody in Canada knows that Toronto is the center of the universe, and for astronomical research, education, outreach, it is certainly a center of the universe, and that's what this is about. So here's the caveat. I'm an astronomer. John is an astronomer. I'm not a historian. At best, I'm a sort of amateur historian. We leave the real stuff to people like Randall Rosenfeld and Peter Broughton and people like that. But anyway, this is my take on it. And it began as an IYA project because I was a supporter of Heritage Toronto, and I went on their heritage walks, and I thought it would be really neat to develop a heritage walk for some of the interesting sites around Toronto, and that's what I'm going to show you here. So you remember IYA, 148 countries around the world. In Canada, over 3,600 events, most of them organized by the RASC and the FAQ. Thank you very much. A wonderful occasion, and one where we wanted to start to reach new audiences. Now, the other caveat is that, in fact, astronomy has been going on in the Toronto area for thousands of years because it's been inhabited by our Indigenous people, and they have traditionally used astronomy as a clock, a calendar, a compass, and as part of their own culture and their own spirituality. But that's not something that I'm going to talk much about here, even though it's an interesting and very important topic. So if you ask people about the history of astronomy, they usually think about these people here, people like in the Copernican Revolution. But remember that, first of all, this happened in Europe, and secondly, it was going on in the 15th, 16th century when not very much was going on in the Toronto area, certainly in terms of what we would think of as astronomy. And astronomy progressed through the 18th century. There was an allusion yesterday to this wonderful book by Richard Holmes, which I recommend very highly, and it explains how the wonder of science developed and also how science became connected with the arts, as we also saw yesterday, and the rise of public lectures and demonstrations and talks and museums and so forth. That is the involvement of the public in astronomy, which is also a theme of this particular meeting. So just to give you a sense of what was happening in Toronto in those times, it became the capital in 1793, but at the time of the War of 1812, there were only a few hundred people in the Toronto area, and I suspect very little astronomy. But by 1834, York had become the city of Toronto, and by 1850, this was a major center for industry, banking, transportation, and so forth. We even had a charter for a university, but I'll say a little bit more about that later on. So it starts pretty much in 1840 when the British Admiralty was engaged in an international project to understand why compass needles tended to wander on timescales of weeks, months, and years, which was an important issue as far as transportation was concerned in those days. So they set up little magnetic observatories at a few sites around the world, including in Toronto on the site of what's now the University of Toronto campus. But after a few years, they more or less solved the problem. They determined that it was due to solar terrestrial relations. They packed up their observatory and took it back to the mother country. And that would be the end of the story, except that this was the time when Canada was beginning to feel its oats. And so it decided that there was a need for a proper observatory built by Canada as a center for magnetic meteorological astronomy, very much practical astronomy at that particular time. So they erected this building here in the 1850s. And this building still exists, not as an observatory, but it's really one of the most important scientific buildings in Canada. So in those days, as I mentioned, astronomy was primarily of interest because of its practical applications. This is a picture here of what a Heritage Toronto walk looks like, and we'd stopped at this particular pillar, which you see at the bottom there, and on it there's a plaque that presents the precise latitude, longitude, and elevation of that point. So this could become a standard for surveying in the Toronto area and then beyond. Surveying was important as the Trans-Canada Railway was being built and so forth. And at the same time, there developed public interest. I mentioned earlier that in the 18th century, at least in Europe, there started to be public interest in the sciences, and that was often done through organizations called mechanics institutes, which implied that it was for people of the middle, lower class to become educated, to have access to information, and so forth. And that's what these mechanics institutes did. The Toronto one, or the York one, began in 1830, and although you can't read all the writing on that plaque there, which is a Heritage Toronto plaque, that this evolved into the Toronto Public Library, which is now the busiest public library system in the world. So an interesting connection there. Well, I mentioned Trans-Canada Railway, and one of the most important people, certainly a name that Canada should be familiar with, is Sandford Fleming, engineer, surveyor, map maker, and so forth, very much involved in the Trans-Canada Railway. He also designed Canada's first postage stamp with our national rodent on it, and a lot of other things, including the foundation of the Royal Canadian Institute, which I'll mention in a minute. So the Royal Canadian Institute is Canada's oldest existing scientific society. Now, for the people next door in the AAVSO, or primarily from the US, it sort of corresponds to the state academies of science, which have a rather similar role, or at least did, in the US. But it provided a forum for people from various disciplines to come together in a serious way and discuss important issues. And one of the famous issues, going back to Sandford Fleming, was the issue of standard time, which was very important in terms of the railways, which of course Fleming was very interested in. So he is best known for his promotion successfully of the system of standard time that we have today. Well, there will be a few people who are interested in getting together to discuss astronomy. And so in December 1868, a group of people came together to form the Toronto Astronomical Club, which over the years has evolved into the Royal Astronomical Society of Canada. So if you do your math, you'll realize that last year they celebrated their 150th anniversary. They've developed into the organization that we know and love now, with members around the world, a very active program of public education, winners of the the prestigious Michael Smith Award for Excellence in Science Outreach, and a tremendous variety of activities which you'll certainly hear about today. So they had a wonderful year last year, commemorative stamps, commemorative coins, all kinds of wonderful activities that went on, very much oriented towards the public as well as towards the members themselves. Well, this brings us then to another aspect of astronomy, and that is the universities. Now, the University of Toronto was chartered in 1827. Problem was that they couldn't agree whether it should be an Anglican university or whether it should be non-denominational. So the Anglicans went out and they formed their own college, Trinity College, elsewhere in Toronto. And those of you in Toronto know where it was because it's now Trinity Bellwoods Park. And it wasn't until the 1850s that the actual University of Toronto was constructed in this particular building here, which we now call University College. It's undergoing a revitalization, which is very exciting to me because I'm a graduate of University College. And so this is very much the icon of the University of Toronto. Now, when it was founded, the teaching of astronomy would be pretty pathetic, to be quite honest. There was a bit of descriptive astronomy within some of the courses. There was a very specialized course in mathematical astronomy, sort of 16th century stuff for the math majors, but not too much else. And meanwhile, I mentioned Trinity College having formed separately. There were other religious colleges formed, one being Victoria College, the Methodist, now United Church College, originally located in Coburg. Now, one of the interesting things about Victoria College is that its founding principal, Egerton Ryerson, is a very important person in Ontario and Canadian history. He's largely responsible for our famous public education system. He has a university named after him in downtown Toronto, and he was involved in many other things that have their, still have their results today. But as the principal of Victoria College, in his inaugural address, he uttered these words here: "Surely the knowledge of the laws of the universe, and the works of God, of course, is a more practical advantage socially and morally than the knowledge of Greek and Latin." Now, I don't know about you, but I had to take Latin when I was in high school, but there was no astronomy on the curriculum, and that didn't get corrected until about 20 years ago. So, in a sense, then, Ryerson was a proponent of the teaching of good astronomy as part of the university curriculum. Now, another interesting connection is that the Victoria College building, which I'll show you in just a minute, well, we can go back here. This is the Victoria College building as of 1892, when Victoria College amalgamated with the University of Toronto. And in that building there is housed the Institute for the History and Philosophy of Science. This is where the professional historians of science hang out. And although universities are rather siloed, as any of you who've worked in them know, we did, as part of IYA, establish some interesting partnerships with the Institute for History and Philosophy of Science and Technology. This is one of the exhibits there on the third floor of what we call Old Vic. And we discovered that the graduate students in history of science were doing a very important thing. They were creating a virtual museum of scientific instruments from the history of the University of Toronto. And of course, it jogged us, the astronomers, to cooperate with this and start to conserve and catalog the instruments, including the ones from the Dunlap Observatory, et cetera, et cetera. But if you go on this website here, utisic.org, you'll see this wonderful collection of scientific instruments going back to the 1850s. It's very much worth checking out. Now, you're all familiar, I think, with transits of Venus, and they've occurred a number of times, most recently 2012, which I'll mention a little bit later on. But the observatory did purchase a telescope for that, which had an interesting subsequent history. Sadly, it was clouded out because the transit was in November, and everybody knows what the weather is like in Toronto in November. But they did try. So that brings us to Chant. Chant has been mentioned a number of times yesterday, played a number of important roles. He was a professor in physics. He built up the astronomy program and department. He wrote and lectured extensively, leading to the donation of the Dunlap Observatory, opened in 1935, and he was the guiding light for the RASC for over 50 years. Now, most images that I know of Chant are of him in his older age, and he looks rather cadaverous. So I was very happy to get this image here of him when he was in his third year of university. And so he's in the back row on the right. So back row, right-hand side there, that's Chant 1 year before his graduation. Now, when he graduated, he worked for a year or two in doing various things, but then he came back to the University of Toronto as a professor of physics in 1892, and he immediately, well, not immediately, but over the next few years, he did a number of very important things and quite remarkable, I think, because I know a little bit about university administration. So he established a separate budget within physics for astronomy. He created new courses and labs which were up to date. He actually spent a year at Harvard getting his PhD and absorbed modern astronomy at that point. Campaigned for a major telescope that led to the Dunlap Observatory, created the Department of Astronomy, and I think we're now the only separate astronomy department in Canada, and many more things, which were quite remarkable because he was the only astronomer in the department. He didn't initially have a PhD. He was never involved in research, but yet he managed to do all these remarkable things. So if you look now at the University of Toronto, and Toronto in the turn of the century, that is around 1900, first of all these independent religious colleges wanted to affiliate with the university. Likewise, there were professional schools, education, medicine, engineering. They had been separate. They wanted to affiliate with the university. So the university absorbed these and suddenly had the need to teach a lot more students. So they needed new buildings. They needed new faculty, which was probably a good thing for Chant. So he got a job at the university. And particularly the need for new buildings. So here's one of them. This is the physics building of 1907. Briefly, it was the home of astronomy at the university, but most of the astronomers were actually based out at the Dunlap Observatory. It burned in 1977. It was rebuilt and became an electrical engineering building and named after Sandford Fleming. So this is the Sandford Fleming building. Right next to it is our Convocation Hall, 1905. The problem being that these buildings are exactly where the old observatory was. So what's going to happen to the old observatory? Well, it was to be torn down, but then some bright light decided that you could just take it apart block by block, move it to some other site where it was out of the way, and indeed it was moved to another site a couple of 100 meters away, and there it sits still on a little hill next to Hart House, and it's now the home of the U of T Student Union. So the dome gets painted some interesting colors. I think you got a sense of that yesterday with the observatory at Western. So the Western students occasionally will come and they'll paint the dome purple or something like that. But the building still exists, so it's an important existing historical scientific building in Toronto. The Meteorological Service moved up to Bloor Street. Those of you from Toronto will probably know this building on Bloor Street next to Varsity Stadium. It's now repurposed as the Monk Center for Global Affairs. An absolutely beautiful building there. But what people tend not to see is a little building immediately to the right of it, immediately to the west, which is this little building here with strange windows that are about 4 feet high and half a foot wide. And that's where the telescope peered through in order to observe stars as they were crossing the meridian. So that was part of the work of the observatory. Very close to that building, in fact, is the Royal Ontario Museum. It's just past its 100th birthday there. I could go on for a little while about this because the museum hosted the McLaughlin Planetarium, which sadly closed down. One myth is that there's no astronomy there anymore, but they do have astronomy with portable planetariums, some education programs, and they have an absolutely wonderful collection of meteorites, and they've just announced the beginning of building a wonderful new gallery on the dawn of life, because one of their strengths is in paleontology and things related to that. But anyway, one of the things that I associate them with, because I go back 50 or 60 years, is their interest in meteorite impact craters. And it was because a prospector by the name of Fred Chubb came to their geology department and said, look, I found this strange circular lake in northern Quebec. What's going on here? So they sent an expedition, and then the next year they sent an expedition financed by National Geographic, which meant that it was all nicely written up in that National Geographic magazine. And since then, Canadians have gone on to become world experts in the field of meteorite impact craters, and that's a whole new topic to itself. What the ROM does have is an excellent collection of meteorites, particularly very rare ancient meteorites like carbonaceous chondrites, which have been largely unchanged since the birth of the solar system. And that's found in the Mineralogy Gallery, which I highly recommend to any of you that are in Toronto or visiting Toronto. Which brings us to the Dunlap Observatory, which was well discussed yesterday. This was an outcome of chance interest in doing public outreach. He got David Dunlap interested in it. After Dunlap's death, he convinced Jesse Dunlap to make the donation of the observatory to the university, at which time it was the second largest telescope in the world. The third largest was in Victoria, so Canada was in a quite remarkable position astronomy-wise at that time. Now, you'll hear something about the Dunlap Observatory if you go on the tour, and I won't go on too long about this because it's of a very complicated story. Suffice it to say that the observatory is now owned and operated by Richmond Hill, the programming being done in part by the RASC Toronto Centre. So it's still an active centre for public education in astronomy. It's probably best known for Tom Bolton's co-discovery of the first black hole in space, done with the 74-inch telescope, and discovering that the X-ray source, Cygnus X1, was actually a 6-day binary system of a massive normal star and a black hole. And that's another story all to itself, but certainly a very important finding in the time when the observatory was very active in terms of research. Its most famous faculty member you heard about yesterday, Helen Sawyer-Hogg, known particularly for her weekly astronomy column in the Globe and Mail, in the Toronto Star, but for many other things as well, as a pioneer woman, physical scientist, leader, administrator, teacher, and all those things there. And she's proudly wearing her Companion of the Order of Canada insignia there. So this brings us then to about 1950. The university survived the Depression and the Second World War, and by 1950 the service people had come back. They were offered free university education. So many of them wanted to do engineering that a separate campus was set up in Ajax to the east of the city there. And general expansion of engineering facilities. The influence of aerospace from war efforts, electronics, computing, all of these things had come out of the Second World War, and then were accentuated by the Cold War and Sputnik and so forth. So a tremendous increase in interest in STEM education, and not to forget the baby boom that occurred starting in the late 40s, and this hit the school system, hit the universities in the 1960s and so forth. So one of the outcomes of the interest in engineering was a partnership between the astronomy department and electrical engineering, particularly Alan Yen, which led to, among other things, the development of very long baseline interferometry, which is responsible in part for this famous image that you saw a few weeks ago, in which multiple radio telescopes can observe a source with very, very high resolution. So this technique was basically developed right here in Canada. Computing, if you read my column in the RASC, then you may know that my last column was about the way that computing had changed during my career. So, for instance, on the left-hand side here, we have a room full of electronics that you could now put in your pocket, but astronomers were among the first to make use of computers for scientific work. On the right-hand side there is Dr. Beatrice Worsley, Canada's first female computer scientist, and interesting story. Tuzo Wilson was actually my first boss, because after he set up geophysics at the University of Toronto, he went to become principal of the University of Toronto at Mississauga, where I started in 1967. But he really put geophysics on the map as a discipline, responsible very much for the concept of continental drift and so on and so forth. And that has gradually evolved into work in Earth and planetary sciences. We have a major planetary science center at the Scarborough campus of the University of Toronto. And public interest led to the McLaughlin Planetarium, set up in 1968 as a joint project of the RASC and the Astronomy Department, and hosted by the Royal Ontario Museum, which until that point was actually part of the University of Toronto, and then in 1968 it became independent. Sadly, it closed down in 1995 for essentially political reasons, but that's a long story in itself. But it was a wonderful facility while it lasted. It was the home of the RASC Toronto Centre, et cetera, et cetera. Well, when the baby boom hit the universities, one thing that U of T did was that created as part of the university essentially the beginnings of York University, where you are now. And after that, York moved to a campus called the Glendon campus on Bayview, and then to this campus here. And that was 1965, and in the meantime, this campus has grown to become one of the largest universities in Canada. And a major center, as you probably have figured out by now, for astronomical research, and particularly space physics, but particularly public outreach. They have an enviable public outreach program here, much of it run by the students, and much of it responsible to, much of it attributable to Paul Delaney, who I wish could be here today to get credit for all the wonderful work that he's done here. The University of Toronto established two new campuses of the university, Scarborough and the one in Mississauga, where I started in 1967, and a number of important astronomical achievements there. The studies of the magnetic properties of the moon samples brought back by the Apollo mission. That's where Tom Bolton was teaching when he co-discovered the first black hole in space. Roberta Bondar, the first woman astronaut in Canada, she did her PhD there, and so forth. We've just passed our 50th anniversary, and again, if you check out my columns in RASC, you'll find one about this. And the Science Center, this year celebrating its 50th anniversary. It was a late centennial project for the province of Ontario, now home to the RASC Toronto Centre, along with some wonderful exhibits, particularly this year celebrating their 50th anniversary, and exhibits that are focused on space because of the 50th anniversary of the first landing on the moon. Well, I mentioned that the observatory was no longer active, and that was partly because much better sites for doing astronomical research had been discovered, and it became practical to go to places like Hawaii and to Chile. And partly for those reasons, we were able to obtain the funding to set up a small astronomical observatory in Chile, University of Toronto Southern Observatory. And that, at least by Bob Garrison's calculations, was the most productive observatory per dollar spent anywhere in the world. And sadly, it didn't last forever. Cutbacks in Canadian government funding led to that actually being moved to Argentina. But it was there that Ian Shelton discovered supernova 1987A. As you know, the brightest supernova in 400 years. Another important development, not very well known among the public, is the Canadian Institute for Theoretical Astrophysics, hosted by the University of Toronto. Dick Bond is longtime director and eminent astronomer, a recipient of the Gruber Cosmology Prize, which is kind of like the Nobel Prize for cosmology, and so forth. You heard a bit yesterday about astronomy in space and the work done by the U of T Institute for Aerospace Studies. This is the Hubble Space Telescope here, and yesterday you heard from Greg Wade about Bright, our constellation of nanosatellites. A cheaper way to go at least to near space is by high altitude balloon astronomy, which is another thing that we've been involved with for 10 or 15 years. Among other things, it allows a few of our graduate students to go to Antarctica, because that turns out to be the best place to go and do long-term ballooning without the day and night cycle interfering with the balloon. And so studies of the microwave background radiation, the emission from the Milky Way and so forth have gone on there. So the Dunlap Observatory did close down. The lands surrounding it were sold to a developer. The proceeds were used to endow a new institute, which doesn't have a fancy building. We just have an old building. We have no fancy instruments other than the ones that we build ourselves. Our objectives are observation, instrumentation, education, and public outreach, which I'll say a little bit more about tomorrow evening at the banquet. But the important thing is that this carries the Dunlap donation into the 21st century, and the family is very, very supportive of the work that's going on, and the way that their donation is still as rich as ever. These are my colleagues in the Dunlap Institute. I show that because when I give this public lecture, you know, a lot of people think I am a typical astronomer, a graying white male, and I like to show people that these are the astronomers of today, and we're very proud of our diversity and our values and so forth. A word about teaching. Things have changed a bit since Chant's time. We teach courses of 1,500 students in Convocation Hall. We do it very well because I have colleagues such as Michael Reed, who are using the best pedagogy, the best technology, the best teaching approaches, supported by small group tutorials in our small planetarium. Yes, we still have a planetarium here, and right up to a graduate department with students from all over the world. We do public outreach, as does the RASC and so forth. So on the bottom, a typical star party from the RASC. At the top, one of our most interesting outreach events. This was part of an audience of 5,000 people in Varsity Stadium observing the 2012 transit of Venus. It was actually perfectly clear, and the seats were perfectly aligned to watch the transit. And meanwhile, the transit was being piped in from Hawaii on the Jumbotron and so forth. So public education is an important part of what we do. Thousands of people gather for an eclipse of the supermoon. The sky was cloudy, but luckily we had dozens of astronomers there to keep the crowd amused and so forth. One of my favorite IYA activities was to do with the connection between astronomy and the arts. A wonderful program called the Galileo Project, done with the Tafelmusik Baroque Orchestra. So again, astronomy in Toronto and everywhere else, I suspect, and we'll hear about that from Jim Hesser. The link between astronomy and the arts is certainly alive here. Well, at this point, I show this slide here. It says, "Mr. Osborne, may I be excused? My brain is full and it's coffee time." So I'll simply show you this picture here of UC. Everybody can figure out, I'm sure, that this was photoshopped and done by my research student, Henry Leung, who's now a graduate student. So I will leave up this slide here because I have a website where I have the map for the Heritage Walk. I have the text of the, I have basically this PowerPoint presentation there. Of course, I highly recommend Peter Broughton's book, Looking Up, and Richard Gerald, The Definitive History of Astronomy in Canada. So I don't know if we have time for a question or two here, or whether people, is there a question or two or three? I've gone about 5 minutes over here, so. or do you really, yes?
Hi, thank you, Dr. Percy. I have a very general question about doing astronomy from high altitude balloons.
Yes.
I'm curious how long they stay aloft and at what altitude.
Typically, they can go up for 10 to 15 days. And gee, I can't remember the exact altitude. It's of the order of 100,000 feet or something. So it's above something like 99% of the atmosphere, and that allows you to do microwave astronomy of the cosmic microwave background radiation, which has been the main thing they do, but also studies of the dust emission from the Milky Way. As I say, the exciting thing is that we send graduate students down there, and they're involved in the launch, and they play with the penguins and so forth.
Thank you for the presentation, Dr. Percy. My question is, I've been with you walking twice, and it was absolutely amazing. I was wondering if you're thinking of putting all of this information and more in a booklet or a book at some point?
Well, I did propose to certain publishers the idea of doing a book called Toronto's Astronomical Heritage, and they weren't desperately interested. There's a short version of what I've given in the RASC journal, which you can find about 4 years ago. It was one of my first columns in John Percy's Universe. But I still have at the back of my mind to do this. I do this presentation fairly often in libraries and with various groups. A lot of times during our sesquicentennial year and so forth. And so, as I say, at least my PowerPoint's available to people who are interested. I think if I went any further, I'd have to do some proper research. And as I say, I'm at best an amateur historian.
Thank you.
Thank you very much. I understand that you've done some work with high school co-op students doing some astronomical research. And I'm wondering if
yes, I'm going to mention that tomorrow evening at the banquet if you happen to be there. But no, for about 25 years we had a program whereby senior high school students could work with us on research projects, just as our undergraduates do. And that was actually terminated because they determined that these students were not preferentially going to U of T, they were going to Harvard and Caltech and so forth. And despite the fact that it was really a wonderful experience for the student and for me and for their school and so forth. But I have some wonderful stories about that because I still keep in touch with many of these students. Some of them have gone on to quite brilliant careers already. They've won Rhodes scholarships and so on and so forth. So the point that I'm going to make tomorrow evening is that high school students can be wonderful collaborators in your research or in your public outreach or whatever. And so they're a population that we shouldn't ignore when we look for people to help us to do astronomy. I'm sure you're desperately waiting for your coffee break. I am. Thank you.